Thanks FlexSeal for sponsoring this video and powering our science mission. Hi, I'm Mark from Team Dominator. Last fall, with help from our friends at FlexSeal, we created the Gravitron sensors. Gravitron is designed to measure high-resolution temperature, pressure and humidity in severe weather. At the end of January, we deployed Gravitron into a bomb cyclone in Sandwich, Cape Cod, Massachusetts. Sensor 8 gave us some strange results, which I'm going to discuss here. The sensor was deployed 50 miles southeast of Boston, just off the bay. It was attached with grey flex tape. Over to Reed to discuss the deployment.
So I have now returned to the point of deployment. This is the Sandwich Boardwalk. This area was hammered by 3 to 4 feet of storm surge, winds gusting over 80 miles an hour, and about 18 to 20 inches of snow. And I deployed, using flex tape, the Gravitron sensor to sample those gravity waves right on that pole. And I can already see it, that it made it. Boom. There it is. Does appear to have taken a little bit of icing on it. So this entire area was underwater, and you can actually see the water line here. There's the ice. This whole area was under a foot, foot and a half, even a couple of feet of water. You can see the boardwalk got lifted up as well from that surge that came in off of the bay. You can even see a little bit of rime. Accumulation of the snow and spray there on the backside of the sign, suggesting that it was obviously downwind of that little pole there, but open, not a lot of structures at all upstream, so it should have been unimpeded.
So this is the data that we got from the rogue sensor, sensor number 8. Note the highlighted area here. Pressure declined further than it should, and then it suddenly corrected back to regular levels. For comparison purposes, this is sensor 5, which didn't have the same issue. Note how the pressure declines and rises as the bomb cyclone passes. And here are the sensors overlaid. The rogue sensor is in red. Putting our heads together, we came up with a few possibilities. The first possibility was that the pressure excursion was real. This one was unlikely because a 40 millibar pressure change in 1/3 of a second seemed implausible. The next candidate was surge water. And as Reed discussed earlier, the water didn't reach the sensor, and if it had have reached the sensor, we would have seen a pressure rise, not a pressure fall. That left us with one possibility, and that was ice accumulation on the sensor. What didn't make sense to us was that ice accumulation was causing a pressure increase and a pressure decrease. So to find out if this could be the cause, we decided to run a simulation. So I opened up the freezer, covered the sensor with water, and froze it down to around -40 Celsius. Here are the results. Note the 2 flat spots in temperature. This is where the phase change happens from water to ice and ice to water. Latent heat is the energy that's required for the phase change of the water. During this phase change, energy is added or subtracted from the system, but the temperature remains the same at 0 degrees. After the water freezes, pressure drops far below ambient and then rises suddenly. This matches what we saw with sensor 8. The sudden changes in pressure we're seeing is being caused by the stresses and strains within the ice. This means we can trust the data before and after, but not during the icing. Thanks for listening. Flex on.